Hello guys, welcome to another video. If you like my work, please like, share, and subscribe. That means a lot to me. Today we're going to do question 4 from the same unit 3, October 2024 that we solved in some previous videos. So here we go. Um, a student determined the mass of a meter rule using the apparatus shown. When the meter rule is in equilibrium, the relationship between the distance k and the distance L is given by the formula where MA, MB, and MR are the masses of mass A, B, and the meter rule. Explain how a graph of K against L can be used to determine the value of MR. 2 marks question, and every question 4 in unit 3 is related to graphs. So in the first question, the first part is always very similar. They give you a random equation and they ask you how you would find something using a graph in this equation. So um we have these things. Now the graph they're telling is of K against L, and we have to find MR, the mass of the group. So the equation of straight line is the equation of straight line y is equal to mx plus c, where m is the gradient of the graph, c is the y-intercept. So we model this equation using the equation of a straight line. So like this means this is y, this is m, the gradient. L is the thing on x-axis plus c. This is the y-intercept. So to find the mass of the ruler, we have to use the y-intercept. The y-intercept is the point where something touches where the graph touches the y-axis. So let's say you draw the graph and it touches the y-axis at this point, then this is the y-intercept. So the y-intercept here would be 0.2 times mr over ma. And then we can just rearrange it to get mr. So this would be ma over 0.2 times the y-intercept. That's it. The part B, the student placed mass A at a distance k from the pivot. She moved mass B until the meter rule was in equilibrium. She then measured the distance L. The student repeated this procedure with different values of k. She recorded the following data. Plot a graph of k on the y-axis against L on the x-axis on the grid opposite. 5 marks question. We have to draw or plot a graph. So k is on the y-axis. So here we will have k and it's in meters. Remember to label the graph. And L is on the x-axis. So here we will have L. Again, it's in meters. Now let's start with L. These are the values of L. They're in decimals, but if you look at the end, it's like 0.075. So just think of 75, and then it's 203, 308, 451, 554, and then the last number is 698. So it's easier to think in terms of whole numbers. So like your first value is 75, your last value is 698. And there are total 6 values. if you plot here, so 0, and then these boxes, there are 8 boxes. Yeah, there are 8 boxes. So this looks like straightforward because we could just do it in terms of like, you know, 0, and then the next one would be 100, 200. So we could use a scale of 100, right? And by 100, I mean like 0 0.1. So 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, and 0 0.7. So all these numbers will lie here. Um, and we can use them to 3 decimal places because our data is written like that. So that's the scale for L. Let's move on to K. K is also in decimals. There are 6 values again. But here on the y-axis, we have a lot of boxes. We have like 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, 11, and like 12. We have 12 boxes. We don't have to use all the boxes. I'm just counting them to get an idea of how to adjust the scale. So again, think in terms of whole numbers because that's easier. So the first one is 80 and the last one is 230. And we have to fit it on this scale of like 10, 11, or 12 boxes. Because again, we don't have to go all the way up to like here. Um, so if we use 50, then we'll reach 23 in 5 values because 5, 10, 15, 20, 25. Yeah. So that would be like our scale would end somewhere here. That would be the graph, like we would be able to plot it, but we would be using less than half of the graph paper, which will cause you to lose a mark. So we choose a bit wider scale, wider or shorter scale actually, yeah. So 40, if we go with 40 again, we would reach 24 in 6 values if we go with 40. Then we have 2 choices. We can either go with 3 or 2. Uh, with 3, we will have uh, 8 values. And with 2, we'll actually have a lot of values. We'll have 12 values with 2. Great. So let's go with 2. So, because again, it's in decimals, so we will, and the first one here starts from 0 0.08. So we can just start from like 0 0.2. We'll start from 0 0.02, 0 0.04, 0 0.06, 0 0.08, 0 0.1, 0 0.12, 0 0.40, 0 0.16, 0 0.18, 0 0.20, 0 0.22, and 0 0.24. Wow, we went all the way till the end of the graph. And that's fine. We can use all the points if you want to. We could also have used the scale of 3. Like we could have started from 0 0.03. Um, I'll remove these points. I don't know why I put them there instead of putting them here. So I think in terms of whole numbers, it's easier to, adjust the scale. But if you're fine working with decimals, you can just do that. Um, let's start plotting now. So the first one is 0.08 and 0.075. So yeah, the first point, 0.075. So again, now over here we would have half of it, 0.05, and then 0.075 will lie in the middle of this and zero point 0.1. So that would be over here. Yeah. And the other point 0.08, so you can go all the way up to here, and yeah. Yeah, here we have the first point. The second one is 0.203. 0.203. So that would be like very close to zero point 0.2, just right to it, just on the right side of it, right next to it. So and the other point is 0.11. Okay, so this is here somewhere. And now let's see where is 0.11. So that would be in the middle actually of this. So here would be 0.11. So we bring it all the way up till here. No, here. Okay. 0.308. 308 again because the line next to zero point 0.3 is 0.31, so it must be like in between the two. So yeah, it will be right next to 0.3, so somewhere here. And the other point is 0.14. Okay, that's straightforward over here. 0.451. So 0.45 is in the middle of 0.4 and 0.5. So this one would be like again right next to it, so over here. And the other number is 0.17. 0.17 would be in the middle of this. Here is 0.70. Okay, here. I feel like doing graphs really strains your eyes. Um, right, 0.554. 0.55 is this, and then 0.554 would be right next to it over here, and that is 0.2. Okay, so we have this would be 0.2 here. Yeah. The last point is 0.23. I'll zoom out a bit. 0.2, 0.698. So this is 0.69, and then this would be just to the left of 0.7. So somewhere here, And the other point is 0.23. So we go all the way up till here, 0.23, this center line. Okay. So now we just draw the line of best fit. And okay. So to draw the line of best fit, let's draw a line that passes through most of the points. So I drew it like this. That's one way of drawing it. Now again, sorry, my drawings will not look really, my line of best fit will not look really great because I'm drawing on a screen. Um, but I can try. So so this is the best I can adjust it. Like right now it's passing through this point, this and this, it's passing through 4 points. And if I were to tilt it to the left, it would just pass through these 3 points. So it should pass through most of the points. That's how the line of best fit works. Um, Now I'll just extend it to draw the to find out the y-intercept because we would need that later on. Okay, this is like seriously drawing graphs on screen is the worst thing ever. But if I extend it like this, I can draw it better by hand, I think. So it would be somewhere here. You choose a ruler, draw an exact straight line, it would be somewhere here. Um, yeah, that actually looks pretty good. So this is 0.07, and then this would be in between the two. So this is like 0.065. Okay. Now, if my values deviate from the correct ones a little bit, just know that it's because I'm drawing on a screen. Now, once we have the graph, we can move on to the other questions. So, uh, determine the gradient of the graph. That's part two. It's 3 marks. We can use the points from here. Gradient is just equal to y2 minus y1 over x2 minus x1. So on y we have k and on x we have L. So a 0.230 minus 0.080 divided by 0.698 minus 0.075. For the gradient, remember that you cannot choose points that are too close to each other. Your points must be at a reasonable distance from each other. So I got 0.24 here. There would be no unit of the gradient because K is in meters and L is in meters. So meters, meter, meter and meter cancel out. Okay, moving on to part 3. It says determine a value for MB, and we're given MA. So let's move back here. No, over here. So MA occurs in like the y-intercept. It also occurs in the gradient. It's also here. So gradient is equal to MB over MA. Let's just use that. Gradient is equal to MB over MA. We know the gradient, which is 0.24. Yeah. So 0.24 times 0.4, and that will be equal to MB. So MB is 0.096 kilograms. Also, over here in like part 2 where we found the gradient was 0.24, but since we're using 3 significant figures, so I'll write it 0.240. And yeah, determine a value for MR, part 4. And now we would need to use the y-intercept thing. The y-intercept was MR is equal to MA over 0.2 times the y-intercept. So MA is just 0.4 times the y divided by 0.2. And the y-intercept, when we found that from the graph, it was 0.065. So this is 0.13 kilograms. So yeah, we reached the end of the paper. That's all. If you guys have any questions or any suggestions, please comment below and like, share, subscribe. I'll see you in the next video. Bye.